Hello, my dear students. I welcome you to this session of Big Data Analytics. I'll be discussing with you in today's session the basics of Big Data Analytics. So let me begin today's session by introducing myself. I am Ajay Sharma, Associate Professor, Department of Computer Science and Engineering, Amritsar College of Engineering and Technology, or ACET Amritsar as it is known, situated in Amritsar. I'm a BTech from NIT Jamshedpur and an MTech from Rajasthan University. Currently, I'm working as an associate professor in the Department of Computer Science and Engineering at Amritsar College of Engineering and Technology, Amritsar. I have a total experience of 26 years of teaching, educating students, programming, and administrative tasks. My areas of interest include programming, databases, big data analytics, machine learning, Python, etc. Recently, I launched my own YouTube channel with the name as Tech-Xpert, in which I would be discussing the various computer-related technologies with my students. So, if you are interested in computer science and you want to have an insight into the latest technologies, then you should subscribe to my channel, Tech-Xpert. So let's formally begin today's session. We are going to have a session on introduction to big data. But before we can, just dive into big data, we must be clear with the term data. So if I ask you guys what is data, obviously the first answer from you would be, sir, everything and anything around us is data. We are engulfed in data. We are surrounded by data. We are consuming data. We are creating data. Data is everywhere. It's around us. But the question is, where does it come from? Well, it comes from everywhere. We speak. That's voice data. We move. That's the sensor data. Sensors are noting down so many things happening around the world. Computers are generating huge amounts of data. Documents are there which are, containing or generating huge amounts of data. So can we classify this data? Yes, we can. Mainly we can classify it into two broad categories of structured and unstructured data. We may have human generated data like emails, blogs, videos, pictures, etc. All these things are done by you. You are sharing emails, you are writing blogs, you are reading, participating in blogs, you are creating videos and sharing them with your friends, you are creating pictures, you are transferring pictures, So that is the human generated data. And we do have machine generated data also. We do have automatic alerts, we have the machine logs, the sensor data is there. But broadly, I would say that we can classify data either as structured or unstructured data. So the question now arises, what is big data? Is it some huge, big, form of data? What exactly it is? So there are many definitions of big data that you will find on the internet. But one classic definition from Wikipedia is that big data is the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. So we now have data sets which are huge, humongous, and we cannot process it using the currently available database management tools or the traditional data processing applications that we've been using for years now. The amount of data has increased. So you see, big data is everywhere. Everywhere we have huge amounts of data. Okay, so it's everywhere. Experiments are there. Research is going on there. Huge amount of research papers are being uploaded, are being shared. Then photo sharing is there. Then CCTVs are there. Social networking sites like Twitter, WhatsApp, and so many others that you use are there. Then the e-commerce sites are there. So selling and buying over the net is there. A huge amount of data is there. Companies are, creating their own portals so that you can, reach out to the thing that you require to the minutest of information, whether it's the price, whether it's the brand, whether it's the quality, whatever is there. So they are providing all that information. So to generate and to maintain all that information, the size of the data has grown humongously. The point of sale terminals are there, mobiles are there. Mobiles are creating and sharing a huge amount of data. Like everything is being done with mobiles in today's world. So mobiles are a big source of big data. So in the slide, you can see that the data has risen, exponentially, I would say. In the year 2005, we had just 130 exabytes of data. And in 2010, it rose to 1227 exabytes. And in 2020, it is expected to be 40,000 exabytes. By the way, what is an exabyte? I think you guys must be traveling somewhere in terms of bytes to a terabyte known as a TB or a petabyte known as a PB. There is a world beyond that also in today's world. The terms have been, they are now originating, new terms are originating. So just to bring you up to date with that, let me just open up one file for you, which you would really, appreciate, is the data sizes. And this is a very interesting, document that I'm going to share with you, because it will tell you that how the data sizes have risen over the years. So I'll just bring this slide slowly, so that you can appreciate. So as we all know that data is in bytes, and 1 byte is equivalent to 8 bits, where bit is a short name and acronym for binary digit. So 1 byte is made up of 8 bits. 1 kilobyte is 1028 bytes, but for simplicity we say 10 raised to power 3 bytes. So 1 KB is 10 raised to power 3, 1 megabyte is 10 raised to power 6, 1 gigabyte or 1 GB as you commonly call is 10 raised to power 9, 1 terabyte is 10 raised to power 12, 1 petabyte is 10 raised to power 15, 1 exabyte is 10 raised to power 18, then exabyte, like we saw on that slide, exabyte. So 1 exabyte is 10 raised to power 18 bytes. Is the next unit after petabyte, PB. Okay. So most of you must be stuck up somewhere here, a terabyte or a petabyte. But we have gone beyond that because the size of the data has increased so much that we need new terms, to denote the data items. So 1 exabyte is 10 raised to power 18. After exabyte, there is something known as a zettabyte, a ZB, 10 raised to power 21 bytes. Then there is 1 yottabyte, 10 raised to power 24. Then there is 1 zennottabyte, known as XB, 10 raised to power 27 bytes. 1 Shilin snowbyte, 1 SB is 10 raised to power 30 bytes. And then the latest one, 1 Dome Game Grotte byte, or which is equivalent to 10 raised to power 33 bytes. So just see how, this data storage, data sizes have evolved over the years simply because data is growing at an exponential pace. We require higher units. So the latest one is the Dome Game Grotte byte, which stands for 10 raised to power 33 bytes. Okay. So let me now go back to our presentation from the point where we left it. So you can see what is 40,000 exabytes. Okay, the huge amount of data, and compare it with 2005. Okay, so it's risen, exponentially. So now let's have a few examples of, the enormous data, or which we call the big data. So Google you are using, it is processing about 25 petabytes of data a day. Facebook has 2.5 petabyte of user data plus 15 TB of data per day. Okay, you're using Facebook, so that much amount of information about one user. You see 2.5 petabytes of user data. So just imagine that there are millions of users. What is the size of data that Facebook is managing? eBay is a e-commerce site, and just see the amount of data on eBay. And stock markets are generating 1 TB of data per day. YouTube generates 40,000 hours of data every day. Just imagine you are, so much hooked up to YouTube, and just see the amount of data that it is, generating per day. 40,000 hours of data per day. Now, these are all our big data generators. I think you are familiar with most of these icons here. Okay, the LinkedIn is there, Facebook is there, Google is there. Okay, so many data generators are there. These are the big data generators. These are the things which are generating big data. Now, the facts before us are very clear that the huge amounts of data is being generated around the world, and the traditional systems are not able to store this huge data. And even if we need to store this huge data, huge cost is involved in increasing the server or the storage capacity. That is the reason that most of the data in the real world remains unprocessed. And another problem on top of that is that approximately 90% of the data is unstructured, and enterprises are unable to process this data using the currently available database management tools. Okay, so these are the facts in front of us. So what we need to do? We need to, we need to store this huge amounts of data that is being generated nowadays. We need to store it, number one. We need to process it properly and quickly. It should not be taking, months for the data to be processed. It should be processed properly and quickly. And the latest thing, the next in thing in today's world is analysis of this data for business or enterprise growth. Okay, businesses are going to improve only if they can analyze their data trends, what the customers want, what are their buying capacities, what are their likings, what are their dislikings. Okay, so the solution to this problem is the use of a software technology known as Hadoop. That is the latest technology that you can use to store the huge big data properly, process it properly and quickly, and then analyze it for business and enterprise growth. So we are going to study something known as a Hadoop. Now, have you ever tried opening a 0.5 GB file for processing on your computer system? You see, a file, a video, a movie file which is opened for viewing is different from a data file which is opened up for processing. Okay, so when some file requires a processing on it, it needs to be first opened up in the memory. So my question is that have you ever tried opening a 0.5 GB file for processing on your computer system? What are the problems that are encountered? How much time it would take, to open this file in the memory, and then how much time it would be required to process this file. So you need approximately 5 minutes to 10 minutes for a 0.5 GB file to load into your memory, in your RAM. Okay, and then processing would require a lot of time as the file size is very big. A 0.5 GB file to be processed properly on your system would first require 5 minutes to 10 minutes to be loaded into the RAM. Okay, and then to process that file you need some more time. Now let's compare it with the big data files. Big data files are at least 1 TB in size. Okay, so you understand the GB and the TB concept. Okay, let me just bring that put in front of you. So what I'm saying is 1 GB, 0.5 GB file, not even a 1 GB, 0.5 GB file requires 5 to 10 minutes to open and then needs more time for processing. And our big data files are at least 1 terabyte in size. Okay, so obviously they are going to require more time for processing. Okay, so what I'm trying to impress upon you is that these files would require a lot of space and for processing, and a lot of RAM also. So to run these files, what you require is yeah, the system is just stuck up. Let's hope that it comes up. Some problems. Yeah. Okay, what we can do is I'll stop this video here and come up with more content in my next video.